Hello everyone, welcome to another video in my channel. In this video, we are required to simplify this surdic expression. We are given root 15 plus root 21 plus root 25 plus root 35 all over root 3 plus root 7 plus root 20. How are we going to simplify this? I am first of all going to let this expression be equal to x. Then I'm going to split the numbers in the roots into their basic forms. For example, root 15 can be written as 5 times 3. That is root 5 times 3. And root 21 can be written as root 7 times 3. Then root 25 is root 5 times 5. And root 35 is root 7 times 5 all over root 3 plus root 7 plus root 20 is root 4 times 5. Now let us make this equal to x. If we apply this property of surds, which is root a times b is equal to root a times root b, in this we'll be able to proceed. So let us split each of these using this property. So it becomes root 5 times root 3 plus root 7 times root 3 plus root 5 times root 5 plus root 7 times root 5 all over root 3 plus root 7 plus root 4 times root 5. Let's remember it is equal to x. Now, having done this, we can factorize common terms out. In the first two terms, root 3 is common. In the second two terms, root 5 is common. So factorizing root 3 and root 5 out respectively from the first, second, and third and fourth, we have root 3 brackets root 5 plus root 7, then plus root 5 in brackets root 5 plus root 7 all over. Now root 4 is 2. That is root 3 plus root 7 plus 2 root 5 is equal to x. Good. 2 root 5 is root 5 plus root 5. So let us still split this one. It now becomes root 3 root 5 plus root 7 plus root 5 plus root 7 in brackets all over. Now I will split this into 5 plus 5. The first 5 will come here, that is root 5 plus root 3, plus the second one will come here, that is root 7 plus root 5 is equal to x. I can still factorize since root 5 plus root 7 is common in these two brackets. So bringing them out, that is root 5 plus root 7. Then put these ones in the bracket, root 3 plus root 5 all over root 5 plus root 3, then plus root 7 plus root 5 equals to x. Let us rewrite this so that the larger number will come first. I now have root 7 plus root 5 in brackets and root 5 plus root 3 in under brackets all over root 5 plus root 3 plus root 7 plus root 5. Now we see this term is exactly this term and this term is exactly this term. So I will make a substitution. I will let a be root 7 plus root 5 and b be equal to root 5 plus root 3. Now putting this inside this, I have in the first case a times b all over a plus b. Let's remember that addition and multiplication are commutative properties. So if I have a times b, it is the same thing as b times a. Also, a plus b is the same thing as b plus a. So switching them does not really matter. Let's remember this is equal to x and this is equal to x. Now, I'm going to take the reciprocal of this. So 1 over x is equal to 1 over ab, which is a times b, over a plus b. Now this will go up, giving us a plus b all over ab. So 1 over x is equal to, I will now separate them into a over ab plus b over ab. Now a will cancel a, remaining 1 over b here, plus b will cancel b, remaining 1 over a. I can still write it as 1 over a plus 1 over b, since addition is a commutative property, as we have seen here. Therefore, 1 over x is equal to, let's remember that a is this, that is 1 over root 7 plus root 5, then plus b is this, that is 1 over root 5 plus root 3. Great. Now let us rationalize the denominators. 1 over x is equal to 1 over root 7 plus root 5 times root 7 minus root 5 all over root 7 minus root 5 in brackets. Then plus, in this part, 1 over root 5 plus root 3 times root 5 minus root 3 all over root 5 minus root 3. Now, talking about rationalizing the denominator, I multiply the denominators by their conjugates. If I have root a plus root b, the conjugate is root a minus root b. So to rationalize, I will multiply the numerator and denominator by the conjugate of the denominator. Since this divided by this will still give me 1. So I will do it to both sides, to both parts of this side of the equation. Therefore, 1 over x is equal to 1 times this will give us root 7 minus root 5. That is 1 times root 7 minus root 5 all over. Since these are conjugates, they obey this property of difference of two squares. That is, if we have a squared minus b squared, it can be written as a plus b, then a minus b. What I need to do is to multiply this term and this term. So root 7 times root 7 is 7, and root 5 times root 5 is 5. Then plus, again, 1 times this is this, root 5 minus root 3 all over. Root 5 times root 5 is 5, minus root 3 times root 3 is 3. Now let me go up. I have 1 over x is equal to root 7 minus root 5 all over 7 minus 5 is 2, plus root 5 minus root 3 all over 5 minus 3 is also 2. Now the LCM is 2. 2 divided by 2 is 1. 1 times root 7 minus root 5 is root 7 minus root 5, plus 2 divided by 2 again is 1. 1 times root 5 minus root 3 is root 5 minus root 3. Let's remember it is 1 over x. So 1 over x is equal to, this and this will cancel out, remaining root 7 minus root 3 all over 2. Now let's also find the reciprocal of this. So x is equal to 2 over root 7 minus root 3. I'll also multiply the numerator by the conjugate of the denominator, root 7 plus root 3 over root 7 plus root 3. And then finish up. X will now be equal to 2 times root 7 plus root 3 in brackets all over root 7 times root 7 is 7, and root 3 times root 3 is 3. So x equals to 2 root 7 plus root 3 all over 7 minus 3 is 4. So 2 here, 1 here, 2, giving me root 7 plus root 3 all over 2. Therefore, this expression, which is root 15 plus root 21 plus root 25 plus root 35 all over root 3 plus root 7 plus root 20, can be simplified into root 7 plus root 3 all over 2. If you find this video interesting, please press the like button. Subscribe to my channel if you haven't done so. Share this video to your loved ones because sharing is love and love doesn't cost a thing. I would also like to read your comments in the comment section. When you do all these things, it will help this channel to grow. Thanks for watching and see you in another video. Bye.